times that is darn near not much. I mean, that's going to be like 0.009. 0.05 times that's going to be 0.0004. And we're adding to this. So I'm going to say this is pretty close to 90. I'll say 89, but it's really going to round off to 90. Now let's write 89 because it's going to be a little different than this. And it's probably going to be 89.9 and then maybe even a couple more nines. And then this times this is going to also be really small. So what you're going to get is like 0.99, bunch of nines here, okay? Right? Then all we do and this is just an exercise in arithmetic at this point. And you know, yeah, okay, I've got to get a 1 here. Actually, I don't have to get a 1 there.
0.
Well, see, now I can multiply my second row by negative 90 essentially, and add to this, right? But I'll call it 89.9 with the caveat that I don't need that there. Okay, let's see. That's not going to be affected. That's not going to be affected. And my matrix is going to be this. Now I'm going to add negative 89.9 times the second row to the third. Okay? Which is going to give me 0. And, okay, 90 essentially. 3/4 of 175, 3/4 of 90, 67.5.
Yeah, 6.742.
Yeah, well, yeah. So we're going to end up with like negative 66.5 ballpark. Okay? And check my arithmetic. So now we've got upper triangular, so there it is. Okay? Now we can do this more accurately with fractions, and I generally advocate that. Okay? But the fractions are going to get really big. So I went with approximations just to show the, so, okay, well, now this tells us that what? If this is E1, E2, E3, E4, E5, then I'm writing this out kind of sloppy because I'm just, that's not 2, that's 1. Okay? Equals U, right? Right? So just taking the inverse of this times both sides, my original matrix is this times this, which is E1 inverse, E2 inverse up through E5 inverse times U. So right there is my L. Okay? Well, time's not going to permit us to write out all the inverse elementary matrices. But they're all very simple, and they're easy to multiply together. And that would give us this, okay? Then we solve this times y equals this column, 6,150, and so forth, right? We get a y, and then we solve Ly equals this, and it's all backward substitution and forward substitution, so there's really no more row operations and nothing but some simple calculations to do. Okay? So, where you are, having maybe reduced down to here, hopefully keeping track of your elementary matrices, the rest is really pretty simple. Okay? A lot less calculation intense. And I do have another board, but we don't have time to do that. Okay? And there's probably an error anyway, so make sure all your elementary matrices are correct and their inverses are correct and see what happens. And if you get it, it's, that's pretty good.